Hello everyone, in this video we are just going to learn what is GSM module and what are all the basic attention commands that we are going to use for configuring this GSM module using TTL module connected to our PC. Let's get started. So here you can see this is the Simcom Sim 900A module which I am going to use in this course, and this one is the USB to digital converter which we are going to use for testing the AT commands in this Simcom module. So regarding the connection between these two modules, we are just going to connect the ground of the Simcom module to the ground of this TTL converter, and Tx of this module, SIMCOM module, will be connected to the Rx of this TTL converter, and the Rx of this SIMCOM module will be connected to Tx of this TTL converter. So let me just make these connections first. So here is the ground. You can see here is the ground of this TTL converter. I am just connecting it to the ground of this SIMCOM module. And regarding the Tx and Rx of this SIMCOM module, I am just going to connect it to Rx and Tx of this TTL converter. You can see here clearly, white wire is the Tx. I am just going to connect this white wire to the Rx of this module. So here is the Rx and Tx. See, white wire is connected to, you can see white wire is connected to Rx, purple is connected to Tx. Here purple is connected to Rx and white wire is connected to Tx. And regarding the SIM slot, I have left the SIM card in the SIM slot open because I am just going to test the basic AT commands with this modem, and then I will plug the SIM card in. And for now I am just going to power up this SIMCOM module with this adapter right over here. You can see this is the adapter which I am going to use, which is a 9 volt approximately 1 amps adapter. You can also use a 12 volt 1 amps adapter instead. And using this power jack, I am just powering up, and I am going to connect this USB to TTL converter to the PC USB port through USB cable, that is mini USB cable. That's all about the circuit connections. Let us test the basic AT commands in this SIM900A module. And now let us open the serial terminal software that I am going to use. That is nothing but Docklite. I have also provided the link for this software in the resources or download button. Just click on it and you can go to the link and you can download the free light version of this software. That is much more enough because we are not going to build our own application in this software. We are just going to utilize this software for testing the GSM module through UART. So that is why it is enough for us to use the light version of this software. I am not going to buy the full version. You are not required to buy the full version of any softwares in my course. And now for setting the port, just right click or double click on this COM5 right over here in the top right corner of the window. Here you can see in this pop-up menu, click on this drop down, and here you can see the USB serial port. Since I have connected my serial port to my PC, it is showing like this. Just click on this and select the baud rate required. Most commonly used baud rate by GSM module is 1,15,200 or 9,600. So basically by default all the GSM modules will be having these two baud rates. My baud rate is 1,15,200 that I found before. So you just check with this 9,600 if you have bought a new module, or if it is not working fine, just choose this 1,15,200 and click on OK. Now the configuration is done for sending AT commands to the GSM module, and for sending this commands, this Docklite provides us with a specified feature called sending a sequence of data at once. So the beauty of this software is this one. I just want to tell you that why I am using this software. Using this software reduces our effort of typing the AT command again and again. Instead, we can store the sequence that we want to send in this storage location of this Docklite, so that each time when I press the send button, that sequence of data will be transmitted through the TTL module. So for storing that sequence, just double click on the sequence tab right over here in the left of the window. You will get this edit send sequence tab. Here, as I said, First and foremost command is this AT command, which is useful for checking whether the GSM modem is working fine. I'm just going to type in AT. You can clearly see the ASCII radio button has been selected, so the type of data that I'm typing is ASCII format. And at the end, as I said, we are just going to provide 0D0A in hexadecimal, that is nothing but carriage return or enter. So select the hex right over here and here type in 0D0A and then click on OK. You can clearly see the sequence has been created. Now when I click on the send button right over here in the left, this AT carriage return LF will be sent to the TTL module and that will be sent to the RX of the GSM module. Since I have connected the RX of the GSM module to the TX of the TTL module, this will be happening. So the main purpose of this AT command right over here, it is an initial command which is useful for checking whether the GSM modem is functioning properly. So for checking that, we are just going to utilize this AT command. So AT must be always followed by enter at the end, as we have did in the sequence. Now for establishing the connection between my TTL module, which has been connected to my USB port, and the GSM module, I just want to click on this play button right over here. You can see the connection has been established. Only the stop symbol has been highlighted, mentioning that if you want to stop, I just want to click on this button. And now when I send this AT along with enter at the end, you can see my GSM module has responded with this message. So this blue message is nothing but the message that we sent from our TTL module to the GSM module, and the message that has been highlighted in the red or the messages that has been given as a response message from the GSM module. So it has sent us the same message that we have sent AT along with enter, and after that it has sent enter, that is carriage return, OK, and again carriage return. And as I said, the response message will be having carriage return in the beginning and also at the end. So whatever the response message that has been sent from the GSM module, it will be always having carriage return in the beginning as well as in the end. So the response message is OK, telling that the GSM module is functioning properly and it has been surrounded with carriage return in the beginning and also at the end. And also in addition to that, we have also get this AT carriage return, that is nothing but the same message that we have sent. So each time when I send this AT command, I will be getting this response message whatever that I am sending. You can clearly see the AT carriage return is being given as a response each time when I send this message. So for avoiding this echoing of messages that we are sending, or for avoiding the echoing of commands that we are sending to the GSM module, we are just going to use another AT command called ATE. So this ATE command is useful for enabling or disabling the echoing of commands that we sent from our microcontroller or from any device to the GSM module. So I am just going to create another sequence. I am just stopping this communication. Double click on this free space for creating the sequence. You can also give a name for the sequence. Disabling echo. As I said, the AT command is nothing but ATE followed by 0 or 1. So 0 means disabling the echoing of characters or commands, and 1 means enabling the echoing of characters or commands. So in our case, I just want to disable the echoing of characters, right? So I am just going to provide 0, and in the hex as usual I am just going to produce 0D 0A at the end. Click on this ASCII tab for viewing the data in ASCII. I am starting the communication. I'm clearing all these things. So now also I'm just sending AT. You can see the response message contains the command that I have sent to the GSM module. Now when I send this disabling echo command, the GSM module has responded with ATE0 along with carriage return, which is the actual command that we have sent. In addition to that, it has responded with carriage return OK carriage return, which means it has successfully disabled the echoing of commands from the GSM module. So now when I send this AT, you can see my AT carriage return has been neglected from the response, and it has responded with only the response message, which is surrounded by the carriage return. That is nothing but OK. Now when I send this again ATE of 0, you can see it is telling that it has disabled the echoing of characters. So in this manner, you can utilize this ATE0 for disabling or enabling the echoing of commands that we send to the GSM module in the response of the GSM module. Now the next command is this Cgmi. So this Cgmi is useful for finding the manufacturer of this module. So there are many manufacturers, right? So there are many people or many companies which is manufacturing this wireless modules. So for finding these manufacturer things and all the configuration things, there is a committee or a standards which is framing all these basic AT commands, which is common for almost all the manufacturers. So whatever the GSM module that you are working on, set of commands will be common for all those GSM modules. So these are all the set of commands which are common. So if you take SIMCOM or Quectel, these commands will be common. So I'm just going to create the sequence for this. Manufacturer AT plus Cgmi question mark, and at the end, as usual, I'm just going to give 0D 0A. Now I'm sending AT, that is producing the result or response OK. Now when I send this AT plus Cgmi along with carriage written at the end, sorry, I just made a mistake. This question mark will not be appearing in this command. I'm just erasing the question mark and I'm clicking on OK. Now when I send AT again, you can see AT is producing me the response OK, and when I send this AT plus Cgmi, you can see the manufacturer of the module is SIMCOM Limited. So it has clearly mentioned the manufacturer name, and the next command that I'm going to utilize is AT plus Cgmm, which is nothing but the AT command, which is helpful for identifying the model of the module. So which model of the module that I'm using can be identified with this AT command. Model AT plus Cgmm, and at the end, as usual, I'm just going to give 0D 0A. Now when I give this model sequence, you can see the model of the module that I'm using is SIMCOM SIM900A. So it has clearly mentioned the model along with the manufacturer for this command. So at the next, we are just going to see another command called AT plus Cgmr, which is useful for finding the software revision for this module. AT plus Cgmr, and at the end, as usual, I'm just going to give 0D 0A, software revision. Now when I give the software revision sequence, you can see the revision of the software is mentioned, and as I said, these are some commands which is common for all the modules irrespective of the manufacturer of the module. Whether it is SIMCOM or Quectel, these commands will stay common because these are standardized by a separate committee in the world that is taking care of the telecommunication network in the world. So these commands will not change depending on the brand of the module that you are using. And the next command that we are going to use is AT plus ICF, and this is, so until this we just monitored and checked the configurations of the GSM module, but here from here on we are just going to utilize these three commands for configuring or for setting the parameters for the GSM module. That is, regarding the UART communication of the GSM module, we are just going to set the baud rate of the UART communication along with the length of the bits that we are going to transmit, and also the parity of the communication also can be configured. So those things we can configure using these three commands. So let me just check what are all the parameters that I can configure. So I'm just going to create the sequence for this AT plus ICF and enter at the end. So for checking the status or the parameters required, just give question mark at the end of this command, and as usual at the end I am just going to produce 0D0A. Now when I send this AT plus ICF question mark, enter at the end, you can see it is highlighting me with response of 3,3, ICF colon of 3,3. Let me just open the datasheet of the SIMCOM SIM900A module. You can see this IT plus ICF is useful for setting TETA control character framing. So it is useful for setting two different parameters. One is the format and another one is the parity. So this first number is showing us the format and the second number is showing us the priority. If the first number is 1, which means 8 data will be transmitted in the UART communication along with 0 parity and 2 stop bits. And when the number is 2, 8 data will be transmitted at a time in the UART communication, and 1 parity will be having, and we will be having 1 stop bit. And if the number is 3, the 8 data transmission will be happening and along with 0 parity and 1 stop bit. So here we got the response to be 3. So 3 means, as I said from the data sheet, 8-bit UART communication is happening with 0 parity and 1 stop bit. So by default it is given as 3. So let me just leave this to be 3. It is no problem that without parity we can operate, and with 1 stop bit it is enough for my communication. And I am just going to use the UART for transmitting a byte of data, that is 8-bit data. And the second parity bit is given the value 3, which is nothing but space of 0. It is also okay for me. I am just leaving it to be as usual. I am not going to configure it anymore. So if you want to configure it, what you want to do is you just want to produce a value like this: AT plus ICF is equal to 3,3, and as usual 0D 0A at the end. Now you can see when I send this command, it is responding with OK. If you give any other number, it will be also accepting it. Now let us move on to the next command, that is nothing but AT plus IPR, which is useful for setting the baud rate for the communication, that is the baud rate of this UART communication that we are operating right over here. So for that we are just going to create the sequence IPR question mark of 0D 0A. Now when I send this command, you can clearly see the baud rate that has been given as a response is 1,15,200, meaning that the UART of the GSM module has been configured in 1,15,200 baud rate. So for changing this, you just want to utilize the same AT command, AT plus IPR is equal to let me change it to be 9600, and at the end I am just going to produce or provide 0D0A. And now when I send this command AT plus IPR is equal to 9600 along with carriage written at the end, you can see the response OK has been given to me, meaning that the baud rate has been changed from 1,15,200 to 9,600. For now, you can clearly see I am operating this Docklite software at 1,15,200. You can clearly see in the top right corner of this window. Now when I send this command AT plus IPR, you can see the communication is not happening, meaning that the GSM modem is not responding. Now I just want to double click on this and I want to change this baud rate to 9600. Since I have configured the GSM module with a baud rate of 9600, now when I send this AT, you can see the response is produced by the GSM module, meaning that the baud rate has been shifted from 1,15,200 to 9,600 or configured to 9,600. So in this manner you can change the baud rate of the UART communication of the GSM module with the help of this AT plus IPR command. And finally we are having this AT plus IFC command, which is useful for determining the data flow control on serial interface for data mode. So for determining the data flow control or for setting the parameters for data flow control of serial communication in the GSM module, we can use this AT plus IFC command. So it returns us with two different parameters like this 0, 0, 1, 1, 2, 2, etc. And the first parameter is nothing but specifies the method used by TE at the receive of the data from TA. So no data flow control is okay for us. Let me just check whether it is having 0 as the first parameter and 0 as the second parameter. So I am just going to create a sequence for this and I am going to produce and I am going to give question mark followed by 0D0A at the end. Now when I give this command, you can see it is returning me with the response of 0, 0, meaning that no flow control has been selected by default in this module. So let it be like that. I'm not going to bother about that. I'm just going to leave it as it is. And that's all about the basic AT commands or standard AT commands required for this GSM module. And also in this video we just learned how we can configure the baud rate of the GSM module, that is the baud rate of UART communication of the GSM module, along with some of the UART configuration, UART parameter configurations like number of bits, parity, etc. So I hope you are clear about the concept and you are able to follow me. See you in the next video. Thanks for watching.